So the exponential function and the log function are inverses of each other, right? That's the definition of a log function. This is the inverse of the exponential. So yesterday we just did converting back and forth. Today we're going to look at actually evaluating these. We're going to skip down to the bottom here. We're going to do these. Evaluate the following logarithms. Okay. I will show you how to use your calculator later on. For now, we're going to do it without a calculator. So when they say evaluate, they're essentially saying, solve it. Give me a number. Give me what x is in this case, or y, or whatever variable you want to use. So to solve this, we're going to change to exponential form. Okay, so how do I change that to exponential form? What is it going to become? What's my base? 3. So the 3 moves over and kicks up the x. So 81 is equal to 3 to the power of x. So this is just like the questions we did beginning of class yesterday and the ones we did just now. We're trying to solve for a variable in the exponent. So the first thing I want to try and do is make a common base. Can 81 be made into base 3? Yes, it's 3 to the power of 4. So what is my x value? 4. So what that means is, you don't have to write this, but that means log base 3 of 81 will equal 4. All right, B. Each one of these is the same. So just put a variable in front, change to exponential form, and let's see what happens. And once you start to get good, you'll be able to do them in your head. Okay? So we're going to change to exponential form. 64 is equal to 4 to the power of x. So 64 in base 4 is 4 to what power? 3. So what's the value of this? 3. Does that make sense? Is that okay? Can you tell me what the next one is? C? 1. So if you change the exponential, you get that. They're already the same base, so x equals 1. What about the last one? 0. So if you change to exponential, what exponent always equals 1? 0. So x is equal to 0. Is that okay? All right, I'm going to flip to the next page. So let's look at these ones. Can you tell me the answer to A? Log base B of 1. It would be 0. Can you come up with a rule for this? Look at that. That's true. But look at this one. And look at this one. When you log the number 1, what is always the answer? 0. Doesn't matter what your base is. If you log the number 1, it will equal 0. So log 1 equals 0. Always. That's good to know, because when we get into more complex things, if you can simplify it down by using that rule, it makes your life a lot easier. This one, I'll provide some formulas at the bottom of this page, or next page. Log base b of b. Who knows? Because it turns into that, therefore you know it equals that. And if you look on the previous page, log base 7 of 7 equaled 1. So I'll just use that formula. And I'll write, if the base, you know what, I don't want to write that yet, because that'll slightly change. So, sorry, just scratch that out. I was jumping the gun. We'll just leave that for now, okay? You want to say, if the base and the argument are the same, you want to say it equals 1. It doesn't always equal 1, but there's a rule based around that that'll make sense in a bit. So put that in your back pocket for a second. Okay, evaluate these. 2 log 8, 512. Okay. So we do this. Then what do? We have to get rid of that 2. So divide it off. Then what? I have log equaling some sort of term. So now I can change to exponential. So I'm going to get 512 equal to 8 to the x over 2. Now I have a number equaling another number with an unknown that is an exponent. So what do I try to do? Common base. Can 512 be made into base 8? So that is 8 cubed. Now what do? So if the exponents, or if the bases are the same, you just look at the exponents, right? So now I have 3 is equal to x over 2. So x is equal to 6. Is that okay? All right. I'm going to hang on before I do the other two, right? Because I want to show you, I won't say better way, but in my mind, a faster way to do it. Okay? But we have to learn a little bit first. So we're going to scroll down to these ones here. We're going to hopefully develop a couple formulas. So I want to evaluate this. Our exponent is a log. Okay? So the first thing I want to do is I want to figure out what that equals. So I'm just going to go over here and I'm going to go, okay, I have to figure out what is the value of log base 5 of 25. Okay? So I'm going to go, okay, it equals x. And then you're going to change to exponential form. And then you're going to tell me the answer is 2, right? Because if you change 25 to base 5, I get x is equal to 2. So that means that this whole exponent here has a value of 2. So therefore, it's 5 to this exponent, which we just said is 2, which gives me 25. Okay. We'll do B, or 2, and then maybe you'll see hopefully we see a pattern. So we're going to evaluate the exponent, log base 7 of 49. What is that going to equal? Change to exponential. So x is equal to 2. So the actual value is 7 squared, which is 'Cause we see a pattern. Just yell it out. Right? Okay, what's the pattern? The number being logged? It equals this number here, right? What's the answer to the third one? 27. The value of this whole thing is 27. Right? If you did that, what we just did, you'd go log base 3 of 27 equals x. The 27 is equal to 3 to the power of x. So it's 3 cubed is equal to 3 to the x. So x equals 3, but that's not the value of the whole thing because I just solved for that. So then you go 3 to the power of 3, which is 27. Okay? So there's a rule here that you need to remember, i.e. write it down on your cheat sheet. If you have log as an exponent, the base of that exponent is a, and the base of the log is a, these match. Base 5, base 5, base 7, base 7, base 3, base 3. If they match, it's whatever n is in this case, but the number that you're logging. So let's just rewrite this. I have a log base a of n. It always equals what? N. Okay. And go down here a bit. Log base a of a to the n. If I said evaluate that, we go, okay, we'll set it equal to x. So then I would change to exponential, and I'd get a to the n is equal to a to the x. So what does x equal? N. Therefore, log base a of a to the power of n always equals n. You should remember those rules, because if you remember these, you don't have to do any of this. If I give you this question, you don't have to do anything except go, oh, it's 49 because of this rule. Okay? So now, let's go back up here. And let's look at this one here. This is what we did before. 2 times log 8, or log base 8 of 512. Blue. 2 log 8 of 512. Well, based on, sorry, I'm going to be moving back and forth here. Based on this rule, if I can make the base of the log and the base of the argument, the number that we're logging, the same, then the answer is just whatever the exponent is on the argument. So if we go back to here, can I make 512 base 8? Can. It is 3. Okay, so I can rewrite this as 2 log 8 of 8 to the third. 8 to the 3 8 to the power of 3 is 512. I haven't changed anything. Does everybody agree with that? So now, based on that rule, right? Log base b of b to the n. So the n. Based on this rule, the fact that these match, ignore the 2, what's the answer? 3. You have 2 in front, you multiply 2 times 3, you get? You don't have to do all this junk. Okay, this is what, in my opinion, makes logs fun. Okay, you can, if you can manipulate the numbers, you can solve stuff very quickly. Okay, so this becomes 2 times 3, which is 6. So now we're going to solve these other two using this method. We're not going to do this long method. Log base 2 of 1 over 32. When you get a question, you always look at these two things. You know, it's 1 over 32, but that doesn't scare us because how do you get rid of a fraction? You can flip it and make the exponent negative, right? So right away in my head, I know I can just do this. And this does take time to get used to, all right? I've been doing it a lot longer than you. But when you get to a certain point, if you practice enough, you will just answer this in your head. Okay. Because when I look at this, I know the answer is -5. All right, just by doing it, you can do it quickly in your head, but you will get to that point. So basically I'm saying, how do I make 32, ignore the -1, how do I make 32 into base 2? 2 to what power is 32? 5. And there's a times -1, right? What's my answer? -5. That's it. You don't have to write all this out, these 2 steps. Right. Until you get good, you can if you want. Let's look at this one. Log base 5 of root 125. Okay, so first of all, can 125 be made into base 5? It's 3. What does the square root mean in terms of exponents? In logs, we don't want square roots or anything like that. We want exponents. So how do you change a square root to an exponent? What power? 1 over 2. So this is the same as log base 5 of 5 cubed and then the 1/2. Everybody agree with that? So what's my answer? Three over 2, because you just multiply these two exponents. Okay. Are there any questions about that? Do you want to do a couple more? All right, let's go to page 236. This is, I know this is pretty different, but it's a very valuable skill. There we go. These guys right here. Okay. Find the exact value of the following. So we're doing the skills that we know. So let me write the rules. Write them up here. So we know that log base b of b to the n will equal n. I know b to the power of log base b of n will equal n. Okay. What's the answer to b? 216, right? Base is max. So it's just 216, and you walk away. Done. Okay. Let's do the first one. A. So 7, 343. I know it's 1 over 343, but what am I going to change about the 343 or 1 over 343 to make it not a fraction? What did I make it negative? Okay, done. Now, the 343 you made into base 7. I can. Anybody know what it is? Sorry? 7 cubed, exactly. 7 to the power of 3. So, and it'll become negative 3, right? Because you'd multiply by that negative 1. What is my answer? Positive 3, because you have this negative here times this negative 3, which gives me 3. C. Square root tells you what's the exponent? 1/2. 1 over 1024, and we want to make it in base 2, so I'm going to have to flip the 1024, right? So it's going to be log base 2 of 1024 to the power of negative 1/2. Half for the square root, the negative for the fraction. Are we good so far? Okay. 1024 be made into base 2? It can. Anybody know what it is? 10. So it's 2 times 2 to the 10. There's negative 1/2. What's my answer? Negative 10 over 2, which is negative 5. And final one. Can 49 be made into base 7? 7 squared. There's a negative 5 there. What's my answer? Minus 10. Done. Is that okay? All right, we need to practice this because it's a good skill to have. So